All right. Okay, can everyone hear me okay? Perfect. Awesome. So let's get started. Mhm. Yes, if you have questions, please use the question and answer option, which is next to the chat. Okay, so let's get started today. We're really excited to kick off this webinar. Thank you so much, anyLogistix, for being an exceptional host for this webinar that we hope is going to be really interesting for you. Welcome, everyone. Let's get started. Okay, so today, let me introduce you the presenters. We have Nicholas Gary with us. Hello, Nicholas. He's our network optimization consultant at Singwell with a wide experience helping customers with the supply chain challenges. And me, Isidro Liñán, a supply chain practice lead at Singwell, looking forward to create an entertaining webinar for you that you take some things from it. We are partners with anyLogistix, and let's introduce really quick Singwell. We are one of the largest simulation companies in the world, and we support companies with their critical decisions, leveraging optimization, simulation, developing digital twins, and leveraging the latest cutting-edge technologies in data engineering and data science. We hope we keep in touch. You will see that you have resources here in the PDF that you can download, in which you will have links to download anyLogistix, go to anyLogistix website, and go to Singwell website as well. All right. Happy to see there is activity in the chat. Let's get to it with the presentation. And let's talk about a VUCA world, right? I think everyone has heard already the term. So let us explain our view of how this affects supply chain leaders. It's almost undeniable that we live in a VUCA world, which is, we live in a world that is volatile, with a high rate of change, with high uncertainty, and with lack of clarity about the present and the future, and complexity, because there are many decision factors that affect our operations and need to be taken for decision making, and there is ambiguity on how all those processes are connected. So many leaders are concerned and trying to figure out how to face operations now in a VUCA world. And let me give you some examples. Okay, perfect. Okay. So talking about the VUCA world, which is a volatile, uncertain, complex, and ambiguous environment, let me give you some examples to put it into context. When we're talking about the VUCA world is because it's affected by things that most likely you will recognize. I'm sure you recognize this picture from disruptions from the Suez Canal. That was something that was not likely to happen, but happened. We have examples from the Baltimore Bridge as well that happened and disrupted supply chains. And then we have another example here in which even the expert had a really hard time to anticipate what will be the demand for 2023. And while they predicted a recession, the economy performed differently, and surprised many of the experts that predicted a recession. We don't have to go that far for finding examples for the VUCA world. And if we look into our operations, we can see that every day we have disruptions, we have uncertainty, we have complexity in our transportation and supply chain, in our internal operations, and there are many, many factors that affect our demand and make it variable and hard to predict. So you will be wondering, okay, that's fine. We live in a VUCA world, but what should we do about it? So we follow the excellent research developed by Gartner. They recommend that we develop key capabilities to cope with uncertainty. And those are really summarized: developing agility, which is the capacity to change, developing responsiveness, which is the speed to adapt that change, and then developing the knowledge of the impact of uncertainty. So being more certain about how to connect the dots and how to make plans to cope with uncertainty. We would like to take this one step further And we propose that we don't only have to cope with uncertainty, but we can take advantage of uncertainty and complexity as we learn how to leverage simulation to deal with a VUCA world. Then you were wondering, okay, so well, we know what we have to do, but how should we do it? So we propose 2 steps to deal with a VUCA world. The first one is accepting reality. There are we have many cases in which we have a deterministic understanding of our supply chain, in which we just consider point estimates, and we propose that we should move it into a stochastic understanding, considering multiple processes in our supply chain and understanding the variability of those processes. And then, second step is once we have our stakeholders convinced about the stochastic understanding, is to introduce variability in our models, talking to our stakeholders, analyzing our data, understanding the variability and the distributions, understanding the policies, and then leveraging a powerful feature in anyLogistix, which is comparing forecast and decoupling forecast with variation. All right. So we're going to have Nick now introduce us in a simple way, an example to introduce variability in our supply chain. Nick, it's all yours.
Thank you, Cedro. Let me just share my anyLogistix. I'd love a thumbs up from you, Cedro, once you see my ALX open.
Perfect, I can see it.
Cool. So today we're going to show off a couple different models and how we can add variability into them. So for my first model here, all these models are relatively simple and just are used as an example of what can be built in whatever situation and whatever type of supply chain you have. So if I go over here quickly to the structured view, you can see here that we have one supplier in factory shipping to 2 separate DCs, and both of those DCs are serving customers on the East Coast from Columbus and on the West Coast from Denver. So if I scroll back in here, you can see where everything is on the map. A couple other pieces I want to point out are the paths table. So if I go click over here in use, take a look at the paths table. It's just a simple product by distance formula using just a 5 cents per product distance. If I go over to our shipping table, we are using just a simple LTL model, so less than truckload model. And then if we go to our inventory table, you can see that there's just a simple min-max policy with days of inventory and safety stocks. So 5 days minimum, 10 days max, and then 2 days worth of safety stock at all times. And then each of these distribution centers have an initial stock. Going into the demand, you can see that just for this first demo, we just have every day a quantity of 200 pallets per customer. So we just wanted to keep it simple off this first model. And then as you can see in our periods table, we use the periods table, which is an awesome feature in anyLogistix that we could just scale up our inventory year over year. So you can see here in year 2, the inventory went up 10%, and then in year 3, an additional 11% on top of that 10. So just check here. We have all these pieces. Now when I go click on our simulation model to run, I'll start it off slow so we can see all the fun nodes, shipping and receiving goods. So you see here our factory is shipping to our DCs, who are then shipping to our customers. And you see all the charts live updating here in version 3.0 of ALX, but let's go right to the meat and potatoes of it. I got a couple more demos to show off today. Perfect. So here, now our model is ran. We have our statistics down here. And as you can see, the model is doing exactly what we told it to. We see 800 units of demand here per customer in total being fulfilled. We see in year 2, it bumps up 10%. Then year 3, it bumps up about another 10%, looking at the small table here. From here, we're going to go into our available inventory. And we can see that the demand increasing year over year as well, along with what is being serviced. From here, we go down to our lead time. And after the warm-up period, we could see that around 3 days, hopefully that is shown. Hopefully that's big enough for everyone to see. You can see our lead time here is about 3 days in our current basic system. Our profit and loss table here, we can see that our profits are larger than our overall costs as shown in this table. If I show all this and bring it out, we can see that our revenue is bigger than our total cost, which is perfect. And our profit is that, let's just say 281 million. Our service level is 100%. By product, it's just that straight line across the bar, which is good. That means all of our customers are being served in this simulation, which is exactly what we want. The last piece here that I want to talk about is our peak capacity and why adding volatility into a model will help give more realistic results. So if you see here, our value of both of the DCs here is about 3,400 at our peak capacity. So all that information would be great if all of our customers act in the same way, that every day they order that same 200 pieces per day, and it's consistent flow of inventory throughout the year. As we all know in supply chain, that obviously does not happen. So going over to my second demo here, demo slide here, now we're going to start adding our first bit of volatility in our metrics. So what we're going to do here is that in anyLogistix, it allows you to, if you see these charts over here, it allows you to add in different types of distributions. So anyLogistix built in has a bunch of, all the main distributions that you'll find, and you'll be able to easily calculate based on whatever forecast or historics you are using. But for just this demo today, I'm going to use our our normal distribution with a mean of 200, so it's similar to our last example, but I'm going to add in a standard deviation or sigma of 50 units. So now this is our first opportunity to bring volatility and bring disruption to our model. So I'm going to click here and save, and then I already have this pre-run to show these results. So if I click here on my statistics, what I want to highlight here is our demand. So previously, everything was just, okay, it goes to 800, then it goes 10% more, and then it goes 10% more after that. Now, as you can see here, it's a more realistic view of what demand would look like. And you can see, after the first year, it does go up slightly. And then after the second year, it does go up slightly more. But now you can see a more realistic volatility in the demand and the fulfillment. Next, we're going to look at our profit and loss table. So if you see over here, our revenue is still still higher than our total cost, which is perfectly how we would want it. But if you could see over here in our profit and loss statement, our profits did go down slightly, and that is because of the increase in facility costs. So right now, our facility cost looks like 93 million, where previously in our last example, it was only about 82 million. That is because of the volatility that we added into the model, and that the facility now is supporting more or less units per the different facilities. Going back to our example with adding volatility, is what I want to show is our peak demand or our peak capacity per place. So previously that was 34,000 or 3,400 number. Now we are all the way up to close to a 39,38 number. So showing this, adding just that slight volatility of that 50 standard deviation to our 200 average will now show a more realistic flow of what our max capacity to be, which will show a more realistic supply chain and simulation. So that is what would happen if you added in demand volatility into your model. Next, we're going to show two different models to go a little bit deeper into how we can add volatility into the model. So what we're going to do here is I have two separate models here, And the function that we're going to use is the gates function to add in a sort of processing time to the model. So if you could see here in my first model, I have one gate. So in this model, I'll have one gate here, and then I'll have a processing time of 3 minutes per unit and with a standard deviation of 1. And then over here, in my second model, I will have 2 different gates with a mean of 6 minutes and a standard deviation of 2 minutes. And I'll run both models to see which one is more effective, which one I would choose if I was deciding, okay, we'll use this distribution center over the other one. So if I look at this first model here, I will go to my statistics. I will go to my available inventory. And as you can see here, the inventory does slightly go up as this goes on, and that is because of the increased demand that we're putting in there. And because now we're adding a processing time, it will slow down. It's not just processing and shipping stuff in and out of the building. There's now an added layer of processing time compared. Next thing I want to take a look at is the lead time. As remember in our first instance, our lead time was about 3 days. Now with the added processing time and variability to it, it now shifts from 3 days all the way up to 4 days. If I highlight this real quick, you can see that previously we were down at 3 and it was consistent. Now we're getting close to 4, and as you see in year 3, that really does shoot up to closer to 4.5, 5 days of lead time between locations. Going into what I want to show now is our profit. You can see our profitability has also gone down between the two, between our previous demo and this demo. And that is because, again, facility costs increased, and now and that's because it considers time, which causes more space in each of the different facilities, which rise that up. And then a main metric is our service level. And as you can see here, our service level goes down drastically because now with the added time, for this instance of having one gate at 3 minutes, as the years go on, it can basically not keep up with the total demand. So this doesn't exactly go down to 0. It does go down to about 50%. So it is showing that it doesn't, it just stops shipping. It just significantly reduces the amount of service, the service level over the years. And then the last piece here that I want to talk about is the peak capacity. So with just this one gate at 3 minutes, it truly does limit the amount that's going through each of these distribution centers. Our first instance, it was at 3,300 number. Our second instance, it was at 39 number. And now we're looking at close to 7,700 as a peak capacity. So just adding these different layers and beginning to add more reality into your model, you could see how these numbers drastically affect. First bit was just adding in the volatility and the demand, and now we're adding volatility into our processing time. So when we look at the 1 gate versus 2 gate, we see a lot of the same different reactions here. So our inventory is going to go up again by clicking the statistics properly. Our inventory is going to go up again as we see year over year. Our profit is a little bit better, but that's because now we could dual source and do or dual process and have 2 different gates working at the same time, even though it takes a little bit it takes a little bit longer. And then our capacity is also slightly lower, and that's just because we have the 2 gates there that can help process more material. And then the last bit I want to show off here, and an awesome feature that anyLogistix has, is our compare experiment function. So what I want to do here is show off that we can, so if I look at my 2 gates function, or my 2 gates demo in here, if I want to compare it to my 1 gate demo, all that I would have to do is click on this button here to add it to our comparison. This one takes a little bit longer to run, so I'm not going to do it live. So I'll just go right to our results here, and we can look at, okay, we are running this process for 50 different replications in our supply chain, which will show a bunch of different variabilities. And now we got these statistics over here to the right. So now we have, just for our profits, our min, our max, and our average profit per per different scenario. And what I'm going to do here is take this information, I'm going to copy it, I'm going to do my best to stop sharing my screen. There it is. Stop share. I'm going to open up an Excel sheet to help me visualize this information. So all I did was I copy and pasted those numbers. I'm putting them down here. And now because we ran 50 different replications of the experiment, what I want to show now is that show the confidence interval with running 50 different experiments here. So as you can see in here, the confidence intervals do overlap. So let me make this a little bit bigger, zoom in a little bit. So all I did here is I went to our scenario comparison. I looked at our profit numbers, and I found our standard deviation error, our coefficients, and then our lower and upper limits. And what I want to show here is just that our confidence intervals do overlap, which means that both results are very similar in reality, but with them overlapping, there might not be that large of a difference between having one gate and having two gates. But now you have all the ammunition you need to be able to share these types of results, to either get buy-in on adding a new gate or adding one or keeping the one gate. But the purpose is just adding in the variability into your models will generate more accurate, more realistic results in the end. So
that was great, Nick. Thank you so much for that great presentation. All right.
No problem.
Okay. Thank you, everyone that is asking questions and contributing. We're going to move into our second demo. We try to do these webinars snappy and to the point, so you guys enjoy and have a good time and have something for you to take away. So let me see if I find the sharing button. It is here, and then I will share my screen again. Can you guys see my screen? Yes. I hope so. Perfect. Thank you, Nick. I appreciate it. Okay, so we have completed the demo one, and then we saw how to introduce variability. So in the second one, and it's good that we got some questions already from the audience about, we're going to see how can we introduce forecasters, and then how can we decouple forecasting and simulated results, which I think is a really powerful feature of anyLogistix, and it can actually help a lot of companies that are stuck with their limitation of their sales and operations software, and they want to show your stakeholders what will be the result of the decisions using their forecast and their estimated simulated demand. Okay, so we're going to show here a simple example in which we're going to compare two models. And in this one, we're going to leverage the shipping policies that we have, the inventory policies that we have in anyLogistix. We haven't mentioned it before. One of the great advantages of anyLogistix is that we can simulate with highly customization our supply chain operations using inventory policies that you see here, using the shipping policies that you will see here, right? And using the sourcing policies. With these three tables, we can really customize and define the policies that we use in reality into our model. So talking about the inventory policies here, a really powerful feature for anyLogistix is that we can select many different inventory policies that you're going to see here. There you go. So we can simulate cross-dock policies, minimum and max. So we have the classical min and max policies. We have order on demand, RQ policies, regular policies, and limited inventory. And the one that I want to introduce today is the material requirements policy. Okay, so we're going to compare, to do this quick example, we're going to compare two models here. One in which we have one warehouse. You will see that this is a little more complex than the model that we showed before, with more customers, but a similar structure, having one factory serving two DCs and those DCs serving a set of customers. I'm going to put it back here. And what we're doing here is comparing the result of using an MRP inventory policy versus not using that MRP inventory policy. So in this model, we're going to see that both of these distribution centers use just a min-max policy in which we only set up the minimum inventory that we have, the maximum order that we have, and what is the safety stock. But in our second example, we're going to use the MRP inventory policy, which is a really powerful feature inventory policy for anyLogistix by anyLogistix, in which we can determine, similar to what MRP processes do in reality and how companies plan their operations, we can see using a forecast that is decoupled from the actual simulated sales, we can determine what is going to be the span that the horizon that we're considering. We can consider the minimum order quantities, multiple order quantities in which it will increment to the maximum order quantity, similar to the min-max capabilities. And then we can consider what is the period of supply. So with this, we consider what is the lead time that we know it will take to serve that distribution center. And the expected lead time, we can determine the safety stock horizon, and the days of safety stock. So this one, you're going to see here that in both examples, if we go to the demand, there you go, we have a more detailed demand is this. We're using each customer has a different demand estimation. In this case, to showcase another distribution available in logistics, we've used uniforms. So you will see that each customer has their own distribution for sales, and they are ordering every 15 days. Okay. And then the difference here is that we're introducing demand forecast. And here, for simplicity, I mean, you can point demand forecast to customers, to specific DCs, to any object that you have already in logistics, which is a really good feature because then you can isolate. Sometimes companies do forecast for specific nodes in their network instead for clients, so you can simulate it here. And you can see that you can upload here detailed forecast. In this case, you will see that in this case, every first day of the month is expected a large demand here of 10,000 units. And then the rest of the days is going to be a lower demand. So this is the forecast that they have agreed to work on. And then we're going to compare the forecast versus the simulated demand that we have there. So let's run this. And inventory, we'll have this one. Okay, so we're going to compare this one. We can see the results here, right? So we have here what is the fulfillment and the results. It's going to take a little. Okay, we're going to see the facility per cost per DC. We're going to see that Lancaster is going to be a little higher. And we're going to close this one. Okay, I'm going to see that the service level, in this case, they go really low when they start moving on. And this is because we have the simple min and max policy that doesn't adapt to our needs. But instead, if we use the MRP policy, in which we have introduced the forecast and we have defined the lead times and the coverage that we need, we're going to see that in this case, right here, our service level are going to improve. Okay. Okay, we're going to have the service levels here. We're going to stay by 1 here. You see here, our warehouse in Lancaster, since we use the MRP policy, is going to increase to 1. Okay. And then we want to compare these two scenarios. We can do a comparison experiment in which we'll compare the both of them, right? So I'm going to compare here against the MRP inventory without the MRP and without the MRP function. We'll have the results here, and similar to what we recommended before, we have our results here in our profit, and using a simple Excel, we can look into our results, right? And we can see that those two results don't overlap, and that indicate that we have a better a better, we can guide into our stakeholders that selecting one policy or the other, we're really making a difference because we don't see the overlapping of their confidence interval. All right, so let's recap here. We hope you enjoyed this quick demo. And to recap, the takeaways here is if you haven't heard it before and or you're familiar with it, we live in a VUCA world now, and supply chain leaders are challenged to cope with the VUCA environment. We recommend to take advantage of uncertainty and complexity by modeling more realistic supply chains and decoupling forecasts and probable results. And your results for your organization will be, you'll be able to support your stakeholders, hard decisions, differentiate noise from triggers, and turn variability into your advantage. It's been a pleasure to be with you. We can have a couple of minutes for question and answers. Nick, have you identified a question that we can answer?
So in the Q&A, there is one question about how to define service level.
Perfect. Great. Yeah. So the service levels here is going to be the products that are served within the expected lead time, which in this case was 3 days for the first example. So you see how that degraded when we had bottlenecks due to the gate, the constraints, and the company was not able to deliver in 3 days. I hope that clarified. And then do we have another question?
How did you create the Excel dashboard for the scenario analysis? So that one was quite simple. We just had a template to calculate the confidence interval, finding the minimum and maximum limits of each. I don't have a copy of what the actual cells were, or the, all the statistics around that. But if you do have the time to Google how to calculate that, it was just a couple different cells in a row there.
Mm-hmm. Perfect. All right, thank you so much. We really appreciate anyLogistix, the host of this webinar. We are partners with anyLogistix, and then we are really happy to support them with their excellent software. If you want more information, you can use the PDF attached to these resources. You will receive a PDF in your email as well. You can download anyLogistix to try it. You can check more events in those links. And you can visit the Singwell website to learn more about how can we help you to have a more effective and more efficient supply chain. It's a pleasure sharing with you what we do, and we hope to keep in touch.